Hi guys, in this very class, you're going to be looking at the second part of the second worked example on balancing complex redox equation. In our previous class, we looked at how to balance this very equation in alkaline medium. And we said we're going to be looking at how to balance this in acidic medium. So in today's class, we're going to be balancing this very equation on the board, this complex redox equation in acidic medium. And don't forget, first of all, we're going to be writing out our oxidation number. We are using the ion electron method. So acidic medium, so the ClO3 minus, which is aqueous, plus SO32 minus, another aqueous, both give us Cl minus aqueous, plus SO42 minus, another aqueous. So let's get the oxidation number. We're solving these in acidic medium. So the chlorine right here, you have a pH, you have an oxidation number, I beg your pardon, of plus 5. Oxygen is minus 2, although there's not a direct player in this. Sulfur here is minus 2 times 3 minus 6. Sulfur is plus 4. Oxygen remains minus 2. Chlorine here minus 1. Sulfur here is plus 6. Oxygen remains minus 2. Minus 2 times 4 is minus 8 equals to minus 2. With minus 2 is plus 6. So quickly, we're going to be working on either the reduction or oxidation first, or likely the reduction. So when you look at the chlorine from plus 5 down to minus 1, this is reduction. While when you look at the sulfur from plus 4 down to plus 6, absolute oxidation. So let's work first on the reduction. This is what we have first, the reduction. ClO3 minus gives us Cl minus. From plus 5 got reduced to minus 6. It means minus 6 was attached to this. So how do we explain that? That's the ClO3 minus, then plus 6 electron. Don't forget, electron is minus 1. So plus 6 electron is plus 6 times minus 1, which will give us minus 6. So when we have this, we end up having Cl minus. So when you look at this, the chlorine here is one atom, chlorine here is one atom, chlorine is balanced. There's oxygen here, but there's no oxygen here. That's where we have an issue. So we have to look for a way to balance out this oxygen. So how do we do that? When it comes to reduction under acidic medium, how do we balance stuff like this? For reduction under acidic medium, don't forget, for reduction under acidic medium, we're going to add hydrogen ion to the reactant end, and then we're going to add water to the product end. So that's what we're going to do right away. ClO3 minus plus hydrogen ion, that's plus aqueous, that's aqueous. It's also aqueous, then plus 6 electron equals to Cl minus, then plus water. So we're going to look for a way to balance this. Let's see if you can easily balance this. So you have hydrogen here, you have water here. This is going to help us balance out the oxygen here. So here we have 3 atoms of oxygen. I'm trying to use the trial-error method. 3 atoms of oxygen here, 1 atom of oxygen. Okay, so when we had, let's add a 3 to this, that becomes 3 atoms of oxygen. 3 atoms of oxygen, oxygen is balanced. Hydrogen becomes 6. Hydrogen here is just 1. You're going to add 6 to this to make the hydrogen balance. Chlorine here is 1. Chlorine here is 1. This is 100% balanced. So we're done with the reduction. As easy as that. So quickly, we're going to turn our attention or shift our attention directly to the oxidation, which is SO32 minus aqueous. Gives us SO42 minus aqueous also. So let's quickly analyze this, the oxidation. So let's analyze oxidation. The SO32 minus brings about SO42 minus. So we'll move from plus 4 down to plus 6. It means 2 was added to this. There is an increment in oxidation number. So 2 added to this to give us this. So how do we explain the addition of 2 to oxidation number? How do we explain the addition? We're going to do that by subtracting 2 electrons. So SO32 minus 2 electron. That will give us SO42 minus. So plus 4 minus 2 times minus 1. So plus 4 minus is minus plus 4 plus 2, which is plus 6. So if you look at the sulfur here is 1 atom. Sulfur here is 1 atom. So the sulfur is balanced. But the oxygen here, we have 3 atoms of oxygen, 4 atoms of oxygen. The oxygen is not balanced. So you have to look for a way to balance the oxygen. And don't forget, when it comes to balancing oxidation, under the acidic medium, we do the opposite of what we do here for reduction. For oxidation, we're going to bring water to this place and hydrogen ion to the other side, just a swap in rows. So that's what we're going to do. We're doing that right away. That's SO32 minus. So water crosses over. We have water plus H2O. That's why we have the minus 2 electron equals to SO4 2 minus, then plus what we have here, the hydrogen ion plus this. So you have water added to this place, then hydrogen ion added to the product end. So we're going to balance the stuff here. So when you look at the oxygen here, you have 3 atoms of oxygen here, 1 atom of oxygen. Oxygen altogether is 4 atoms. Oxygen is balanced. Sulfur is 1 atom. Sulfur is 1 atom. Sulfur also is balanced. Hydrogen, 2 atoms here. Hydrogen here, 1 atom. So I'm trying to use a trial error method. So if hydrogen here is 2, hydrogen here is 1. If I add 2 to this place, it makes the hydrogen balanced also. So hydrogen is 2, balanced 2. Oxygen 4. Oxygen is 4. Sulfur is 1. Sulfur is 1. So we have these also balanced. So everything is well set out. So we have this equation 1. This is equation 2. So what do we do next? The next thing we're going to do now, we're going to look for a way to solve that simultaneously. We're going to be using the elimination method. This is 6 electron. This is 2 electron here. Equation 1, reduction. Equation 2, oxidation. So how do we eliminate the electrons? We have 6 electrons. While we're here, we have 2 electrons. So what's the LCM of 6 and 2? LCM of 6 and 2 is 6. 6 and 6 is 1. We're going to times this with 1. 2 and 6 is 3. Times this with 3. And that makes this balanced. So we're going to use 1 to multiply all this. So 1 times all this will give us ClO3 minus plus 6 hydrogen aqueous, then plus 6 electron. That gives us Cl minus, that's 3, then 3H2O. Cl minus, that's an aqueous there, plus 3H2O. So we're done with that. So the 3 here multiplies all this. So that's 3SO3 2 minus plus 3H2O, that's water, minus 6 electron gives us 3SO4 2 minus plus 3 times 2 there gives us 6 hydrogen ion. So for us to eliminate this, 6 electron, that's nice. Plus and minus, minus. We're going to add to it the opposite sign, which is plus, to eliminate this. So plus 6 electron, plus minus 6 electron, electron goes out. So we're going to add up all this in the reactant end and all this in the product end. So what do we have? We have ClO3 minus plus 6 hydrogen ion, then plus 3SO3 2 minus plus 3 water molecules, 3H2O. They all come together to give us Cl minus plus 3H2O plus 3SO4 2 minus plus 6 hydrogen ion. So everything is well set out. When we look at this, 6 hydrogen ion here, 6 hydrogen ion here, they can take out each other. Then 3 molecules of water here, 3 molecules of water here can also take out each other. So we have everything well set out. Hydrogen ion out, 3 molecules of water, taking out 3 molecules of water. So what do we have? We're going to write out what we have left. This is balanced already. So what do we have left? We have, let me just state it down here. This is our balanced equation. We have the ClO3 minus plus 3SO3 2 minus gives us Cl minus plus 3SO4 2 minus. So guys, this is everything on this very lesson. As you can see, we have this balanced already. So the next thing we're going to do now, we're going to be seeing a couple of questions, to get us tested on how much we've gotten so far on how to balance complex redox equations. So we're going to be seeing some questions right now. Okay, guys, we're going to be rounding off everything on redox equation and complex redox equation with these 2 major questions. So number 1, we are asked to balance ASH3 plus Zn2 plus that zinc ion equals to H3ASO4 plus Zn in both acidic and alkaline medium. So the second question we asked, balance Hg plus NO3 minus plus Cl minus equals to HgCl4 2 minus then plus NO2 in both acidic and alkaline medium. I'm very sure that we have more than what it takes to solve those two questions right. After all, what we've treated already on both non-redox equation, simple redox, and the complex redox. So if you've gained one or two things from today's lesson, I would love you to subscribe to this very channel at EduMosaic and give me a follow on Revelation of on Facebook. And please share this lesson also with others. See you in the next lesson. Thanks and bye for now.